Okay, this is going to be part one of integration by parts. Now the formula looks like this. It's going to be the integral of u dv is equal to u times v minus the integral of v du. Now before we get started on some examples, the overall strategy on integration by parts looks like this. You'll start with some initial complicated integral. So let's suppose that that would be this one right here. So what you've got, let's call this the complicated one. So start with a complicated integral that you cannot find the integral of. Now what you'd like to do then would be to change it into, over here, a simpler integral. So we'll just put simpler here. So a simpler integral that you can find the antiderivative of. Now in the process of doing that, you're going to pick up this u times v, but that just comes along with the problem. So anyway, the overall strategy would be to do this. Change it from a complicated expression here into a simpler expression here that you can work with, and then just take whatever you've got right here. So that's the overall strategy. Now, if the process works right, you will be able to find the antiderivative of this simpler side right here. So now, let's take a look and see a couple things here. As you're working on these problems, you have a choice to make at the very beginning of the problem, is that you have to decide what to pick for u and what to pick for dv. So the idea is something in the initial problem is going to become your u thing, something in the initial problem is going to become the dv thing. And really that's kind of the hardest part, is trying to figure out which one's which. And we'll take a look at how to make that decision as we go through the problem. So the idea is break the initial problem into some u and some dv. So let's take a look at a specific example and see how it works. Okay, now in this first problem, it looks like this, and actually you've got a couple of choices here. So one possible choice would be to do something like this, would be to let this thing right here be your u, and let this part of it right here be the dv. So that's one, and you could possibly solve it that way. As a matter of fact, on this first problem, it'll turn out that's the choice that we'll use. But another possibility is to do this, is to switch these two things right here. Now if you did that, you would have something that looks like this. The integral, and we'll put the e to the x first, then you would have x and then dx. So switch these two around. Now in that case, you would let this one be u, and let this one be dv. So early on the problem you've got is trying to figure out which way should you go. Should you let u be equal to x, or should you let u be equal to e to the x? And at the end of the problem, we'll actually work this thing both ways. The first way we'll work it with the correct choice. The second way we're working with the incorrect choice, so you'll see what happens if it sometimes goes wrong, which it does, by the way. Okay, so back to form again. We're going to pick u and pick v. Okay, now let's go back to this original thing, and what we'll do is we'll pick it a way that will work correctly to start with. So I'm going to let u be equal to, and I think I'll do this in black here, so we'll let u be equal to x, and we'll let dv be equal to this part of it. Now on all these problems I tend to work in this way. It's just divide the thing up into two parts, a u part and a v part. So what I'm going to do is, starting from here and go across like this, I'll just put a line across the page. So put a line, and then I'll put a vertical line coming down something like this. So I've got a vertical line right here. Now what I do is I'll put the u part right here, and I'll put the dv part over here. Now when you work these out, you really need to do this. You're going to find the derivative of the u part, and you're going to find the integral of the dv part. So first of all, start with your choice here. So let u be equal to x, the way you've picked it. Then on this side, you're going to let dv be equal to e to the x dx. So those were your choices. Now again, take the derivative of this part. So on the u part, take the derivative of it. So what that's going to be, the derivative of u with respect to x would be equal to 1. So if the derivative of u with respect to x is 1, that means the differential of u would be equal to 1 times the differential of x, or just the differential of x. So that gets you this. You've got du would be equal to dx. So on this side, you took the derivative. Now, on this side, you're going to find the integral, or the antiderivative. So we'll find the integral on this side. So what you'll do is this. Whatever you do to one side, you got to do to the other side. So I'm going to integrate both sides. Now what I need for the formula, let's go back and take a quick look at the formula here. The formula, I need v. I don't need dv. I've got to find v. So I have to integrate it to get that v. Okay, so what I'll do is I take the integral of both sides. So the integral of dv is equal to the integral of e to the x dx. So integrate both sides. Now just a reminder, whenever you take the integral of dv, if it looks like there's nothing in there, if it makes you feel better, go ahead and put a 1 in there. It makes it a little bit easier to take the antiderivative of it. So the integral of dv, just add a 1, that'll turn into a v. Will be equal to, now you've got a formula for this, we've talked about this one earlier. The integral of e to the x is e to the x, so this will just turn into an e to the x. Now it's also, normally you would do this, whenever you find an antiderivative, if it's indefinite, you put a plus c out here on the end of it. But what we're going to do, you'll see later on, we're going to delay that to the end of the problem, so we'll save this plus c to a little bit later on. If you want to put it in, it'd be fine, it would work, it would just take you a little bit more work, and you'll see that it won't make a whole lot of difference at the end. So let's wait till the end of the problem to put the plus c. Okay, now I've got the things that I need, so let's go back again. The formula looks like this. You started with, here was the integral of u dv, and you change that into u times v minus the integral of v du. So now let's put down the things that you know. What you've got, u is equal to, up here, u is equal to x. So you can put an x right here. Then you've got times v, but v is equal to e to the x. So v would be equal to e to the x, then minus the integral of v. So actually you need v twice. So you'll use v right here, and you'll also use v right here. So v is equal to e to the x. And then finally you need du, and du is equal to, right here, so du is equal to dx. So I'll put a dx right here. So really, on each problem, you really need 3 things. So let's go ahead and put a circle around those. In the problem, you're going to need u, so there is u. You're going to need du, so there is du. And you're going to need v twice, so there is v. So really, those are the 3 things that you need when you get started on the problem. Now it's just a matter of solving this problem. Now what you've done here, just a reminder, you changed it from a complicated expression here. The original problem was a complicated integral that you had trouble working with. But in the process of doing integration by parts, now you've split it into this simpler integral that you can find the antiderivative of. So what that's going to look like would be this. This part right here was still just going to be x times e to the x. Now you can do this. Any part of the problem that you've done previously, you can use again. So this is going to be the integral of e to the x dx. But notice over here, I've already done that. The integral of e to the x dx is equal to e to the x. So this is just equal to minus e to the x. And now finally, I'm going to go ahead and put the plus c on the end. So when I do that, then that's going to turn out to be the answer to the problem. So in this case, the answer would be, and we'll just kind of put a little box around this right here. And you are done. So again, what you did was change it from a complicated integral into this little part down here, a simpler integral that you can find the antiderivative of, and you just accepted the u times v. So there is the u times v, and then the integral of this one turns into this. But you'll need those 3 circle things right there. Now what that is, that's the way it works out if you make the correct choice. So now let's take a look, and suppose rather than letting u be equal to x, suppose we'd let u be equal to e to the x. How do you know if you've made an incorrect choice? Well, let's work that out and take a look at it and see what it looks like. Okay, now what I'm going to do in this case, I'm going to rewrite this thing and make it go like this. I'm going to rewrite it as I'll rewrite it as the integral, and I'm going to switch these two. So I'll put the e to the x here, and I'll put x dx right here. Now this time, I'm going to let this be my choice of u, and this be my choice of dv. Now I'll go through the same process, but here's how you can tell whether you've made the wrong choice or not. And the answer is generally you've made the wrong choice if, when you go through the process, you just don't get anywhere. So let's try it and see what that looks like. So I'll still do exactly what I did before. I'll pick my u and v. So I'm going to put the u thing here. I'm going to put the dv thing over here. And we'll work it exactly the same way. So first of all, let u be equal to, this time it'll be e to the x. Now remember, the derivative of u with respect to x, the derivative of e to the x is e to the x. So that gets you to the differential of u would be equal to e to the x dx. So you need u and you need the differential of u. I think I'll go ahead and put a circle around those right now. So I need, in this thing I'm going to need u, and I'm going to need the differential of u. So now, look at this side. So again, on this side you find, on the u thing you find the derivative. On the v thing you find the antiderivative or the integral. So we'll put integral right here. So start with the definition. dv, and you're getting it right here, dv is equal to x dx. So just like in the last example, integrate both sides. So the integral of dv would be equal to the integral of x dx. Whatever you do to one side, you got to do the same thing to the other side. Well, this will turn into a v. So the integral of dv is just v. And this, use your power rule, that'll turn into x squared divided by 2. And if you wanted to, you could put the plus c out there, but we'll leave that off for right now. So what this is going to give you is v. So remember, in your formula, you need 3 parts. You're going to set it up as u times v minus the integral of v du. So now you can just plug in what you've got. So for u is equal to e to the x, so that'll take care of that one right there. Then v is equal to x squared divided by 2. Then minus the integral of v, but v is x squared divided by 2, and then times, that takes care of this one, then times du, but du is e to the x dx. So this would be e to the x dx. Okay, now here's the problem with this. And then if you look at the previous example, let's go back and take a quick look at that. In the previous example, we had an integral of e to the x dx, and you could find that antiderivative if you got an answer. But now the problem on this one is this, is you started with a complicated integral. If you make the wrong choice when you go through the whole process, you wind up with an even more complicated integral. So now this one right here is worse than the one you had to start with. So put a little frowny face there. Bad news. If you made the wrong choice. So if you can't get anywhere, that tells you that you picked the wrong u. And that's about the best single way of finding out whether you've done it or not. If your choice of u doesn't get you anywhere, pick the other u. Okay, now what that is, let's go back and we'll get rid of this one. We'll take a quick look at this original one again. So this is the one that worked fine. This is where we made a correct choice of u. Now we're going to work one more of these things, but we're going to do this. This was x times e to the x. So on this problem, you did not have to use substitution. But on the next problem, we'll work almost exactly the same thing, but rather than having e to the x, we'll have e to the negative 2x. But watch how much more complicated that makes the problem, because now you'll have to use substitution. But the process will still be the same. So let's try a more complicated example. Now again, the only difference is, rather than having e to the x, you've got e to the minus 2x. Now I'm still going to start out the same way. For my choices of u, I'm going to have this. It's going to be, this will be my choice of u right here. So there's u. And I'll let this part of the problem right here be dv. So you need a u and you need a dv. Now I'm still going to do just what I said before. I like to just divide the page up into a u part and a dv part. So starting right here, I'll come and just put a straight line straight across here. And then go down the page something like this. Now this is going to turn out to be quite a bit longer, as you'll see, so we'll extend this line on down. Sometimes this integral part gets a little tricky. So I'll put the u part here, and I'm going to put the dv part here. Now again, find the derivative of this part. So the derivative of the u part, find the integral of the dv part. Okay, let's try that process. So what this is going to be, I'm going to let u be equal to x. So the derivative of u with respect to x is 1. So the differential of u would be equal to 1 dx, or just dx. So what that gives me is this. In the final thing, I'm going to need a u, so there's my u. I'm going to need a du, so there's my du. Now what I need is v. So I'm going to have to go through an integral to get v. So again, dv is equal to this, so start with what comes out of your formula. So dv would be equal to e to the negative 2x dx. So integrate both sides. So you want to find the integral of dv would be equal to the integral of e to the minus 2x dx. Now this side's pretty easy. The integral of dv is just going to turn into a v. So this means that v is going to be equal to, now this side's not going to be so easy though. We'll just go ahead and write it like this. We'll put it as the integral of e to the minus 2x dx. Now the problem with this is this. This is not just a simple x, so this problem is going to require the old u substitution from way back when. So let's run through this again, and I think what I'm going to do is this. I'm going to do u substitution. But it's a little bit confusing because I'm actually going to use u like we've done in the previous problems, but just keep in mind the u substitution is not the same u that I have up here. You have to think of it as a different u. It's just unfortunate that it happened to be u. So we're just going to do u substitution and solve this. Now what I'm going to do is this. I'm going to let, I need to change this entire thing in terms of u, so I need to get rid of that. Now if you need to, go back and watch the videos on u substitution just to remind you how to do this. So the idea is you pick your u. Now I'm going to let u be the exponent on this thing. So u is going to be equal to minus 2x. Therefore, the derivative of u with respect to x would be equal to a negative 2. So that gets you to du would be equal to negative 2 dx. Now I need to get rid of this dx, so I'll take the negative 2 from this side and move it over to this side. That gives me negative 1/2 du would be equal to dx. Now this thing right here matches up with that dx, so just like we've done back in our u substitution days, I'll go ahead and replace it with this part right here. So what this was my u substitution. I think we'll put a little black box around that. So the u substitution was right here. So there's the u substitution. Okay, now what that does, and again, just concentrate on what's in this right-hand column here. I'll change the problem into and I think I'll still stay with the blue ink here. So all this is still just u substitution. So this means that v would be equal to the integral from e to the u, and then remember replace this dx with what it's equal to, which is a negative 1/2 du. So at this point, it's just strictly a u substitution problem. And I think I'll even go so far as to extend this line on down a little bit, just to make sure that we're still just working in the same column. Okay, so now the next thing to do, here's a constant 1/2, so bring that up to the outside. So v would be equal to negative 1/2 times the integral of e to the u du. So this is all just strictly a u substitution problem. So that means v would be equal to negative 1/2. And now the integral of e to the u is e to the u. And normally you would put a plus c here. Now the last step, remember, is to replace u with what it's equal to. Well, u is equal to negative 2x. So this will finally become v would be equal to negative 1/2 e to the negative 2x. And again, we'll leave the plus c off until later on. So I'll put a little red line right there. So now you have got v. So looking back up at the start of the problem, you've got v, and you've also got u and du. So now what we'll do is we'll continue on this side over here. So starting with things that we know, the formula is going to turn into this. It'll be equal to u times v minus the integral of v du. Okay, so plug in what you got. U is equal to x, so you can put an x right here, times v is equal to, and go down to the bottom of this column, v is equal to minus 1/2 e to the negative 2x. So put that in. So v is equal to minus 1/2 e to the negative 2x. And you've got minus. Now you've got the integral. And now again, you had to put v right here. You've also got to put another v right here. So now put v in again right here. So it's going to be the integral of negative 1/2 e to the minus 2x. So that's v, and now you need du, and du is up here dx. So du is just dx. So this will become dx. So again, this part right here, this was u, this was v, this was v, and this was du. So when you put it in there, it looks like that. Well, now it's just a matter of solving this thing. So what you've got is this. I think I'll do a couple things here. I'll bring this 1/2 in front, make it be minus 1/2 x e to the minus 2x. Now, here is a constant negative 1/2. So I'm going to take this negative 1/2, I'm going to bring it out in front. So two negatives make a positive, so this will turn into plus 1/2, and I've got the integral of e to the minus 2x dx. Okay, now here's where you get a little bit lucky. What you've got is this. This will be minus 1/2 x e to the minus 2x. That's that part right there. Then you've got plus 1/2. Now here you can do anything you've done in a previous step you can use again. Well, let's just put a little box around this entire thing right here. This integral, e to the minus 2x dx, is exactly like what I had over here. So that is exactly the same thing as this right here. So since these two are exactly the same thing, you don't have to go through this whole process again. You can just look way down at the very bottom and you've got the answer. So this integral right here turns into this right here. You've already done the work and already shown it. So you can go ahead and put that in right here. This would be, this integral right here will turn into minus 1/2 e to the minus 2x. Now at this point you will go ahead and tack on a plus c on the end of the whole thing. So we'll put a plus c out here. So now just simplify the final answer. The final answer to the problem would be minus 1/2 x e to the negative 2x. Multiply those two together and you get minus 1/4 e to the minus 2x plus c. And finally you are done. So that one took a while. So the answer is going to look like this. But now just kind of a reminder, let's go back up to the beginning here, is decide on u, decide on dv. Find the derivative of the u thing, find the integral of the dv thing. But just remember, it might take, I'll put a little star here, it might take u substitution to do that. So sometimes finding the integral is a little bit tricky. So you found the derivative of the u and the integral of the e. So here was, if you bring it all the way down here, the integral of this thing turned out to be this right here. Now again, you've got the three things that you needed. You need u, you need v, and you need du. Well, plug in the u, plug in the v twice, plug in the dv. Now again, anything that you've done in a previous step, we'll put a little arrow going over here, anything you've done in a previous step you don't have to repeat before. You can just use this answer again. So since you did it in a previous step, you already know what it is. Then simplify the fractions and you've got it. So that's an integration by parts problem that also required u substitution. Sometimes if you're not lucky, you run across this. So good luck with this.